Greetings and welcome, friends. Mr. Waddy here. We've been talking in section 5.3 about proving triangle congruence using the SAS congruence theorem. SAS, of course, stands for side, angle side, where I know there are two pairs of sides that are congruent to each other, and the A is in the middle of those S's, so therefore it is the included angle between those two. And so I already forget what page this is on, but it's on a page. It's 249, page 5 or section 5.3's homework. Here's some question 9 and 11 coming at you. Question 9, it says, decide whether there is enough information to prove that the triangles are congruent using SAS. So let's see. Right now I've got a pair of sides and a pair of angles. Can I prove anything else with the way the drawing is given? I don't know that.
What?
This angle you're saying? CDB, yeah, I've got that. That was given. That was the pair of angles, pair of sides. Do I have anything else, Josh?
Line BB and line BB are reflexive.
Yeah, reflexive property. Okay, I don't think I can prove anything else. I've got two sides and an angle. Two sides and an angle. Is that sufficient? No, because this is not the included angle. Not included angle. The included angle would be the angle that is between, made up of the two sides that we were talking about.
Oh, it has to be.
Has to be in that order. Yeah, the A is in the middle of those S's. Must be in that order. Okay, so, all right, how about over here? Let's see, that's perpendicular. I could prove that that's a right angle as well by, like, definition of perpendicular lines. I could prove that those two angles are congruent to each other by the right angles congruence theorem or whatever it was called. I could prove reflexive property. ZX is congruent to itself. Can I prove these triangles congruent? No! Ho ho! Ha ha! Check this out. Right, this side and this side have an included angle, but behold, this side and this side, that angle is not in the same spot. It is no longer corresponding. It is no-go, no. So not included. Not included angle. All right, let's take a look at some others. Zooming right along. Question 16. With the proof. All right. I love these, guys. This is great. We're getting to see some proofs here. All right. We'd start off with our given information with the givens. All right. Given, you know what those givens are. They're written over there. Here we go. So the given, it says AB is congruent to CD. I see that. I see that. AB is parallel to the CD. Yep. They labeled that. I believe it. All right. What's another fact that I can write down? Josh. AC is congruent to CA with the reflexive property of congruence, technically. Whoa, that was just like, whoa, slow down there, congruence. What's another fact? Jack? Alternate interior angles theorem, I agree. Because these lines are parallel, they are cut by a transversal. 1 and 2 are in the alternate interior positions, and they will be congruent to each other. I like it. I like it. Also, notice the fact that they labeled those angle 1 and 2 saved us some writing. There ain't nothing wrong with giving something a name, right? You can name it, even though you might get attached to it and one day have to cut its head off when it's your pet chicken and you're 17 years old. But you could name those angle 1 and angle 2, which is way easier than writing angle BAC and DCA, right? Like give it a nickname, right? Just like when you catch a Pokemon and you have the opportunity to give it a nickname. But if you just want to leave it, leave it as like, man, my mind just blanked on Pokemon. All I can think of is starters, but you can nickname starters as well. Fennekin, sure. There you go. Yeah. So let's see. Is there enough information to prove triangle ABC is congruent to triangle CDA? Yeah, how so? SAS. Side angle side. Good times. All right, question 18. I like it. Ooh, different arrangement. Here we go. Whoa, 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 whoa. I got the gimmies. Gimme, 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 gimme. All right. So PT congruent to RT. Bam, bam, believe it. QT congruent to ST. I like that. Now, which triangles am I referring to here? I'm referring to triangle PQT. Okay, so this guy. And triangle RST. Okay, this guy. All right, all right. All right, there's a lot of triangles there, you know. I just want to make sure I know which ones I'm talking about. Could have been these two guys. Could have been like these big triangles. Could have been, you know, this big triangle. Yeah, there's a lot of options there. I might as well make sure I know which ones I'm shooting for so I don't just label a whole bunch of unnecessary information. Okay, what's another fact that I can write down? Yeah?
PQ and STR, angle PQ and angle STR are congruent with the vertical angles.
Yeah, vertical angles theorem. I am absolutely cool with the way that you named that. Full credit, full credit. I would just caution you in the future, once I refer to triangles, that might set us up for a mistake because those wouldn't be in corresponding positions. But you're fine. You're in the clear. I'm even going to leave it up here just so you know that you're in the clear. But yeah, vertical angles theorem is why those angles are congruent. But what? And I think I can label triangles congruent. And I guess we might as well just commit to the ones they gave us. PQT. PQT is congruent to PQT RST. Okay, all right. And the reason? SAS. Ooh, man, good stuff, good stuff. Let's see, last question. This one we might just more verbally discuss. Okay, here we go. All right. Now watch this, watch this. All right. RSTUV is a regular polygon. That fact tells me a few things. That tells me this. All of its sides are congruent to one another. All right? It also tells me this. All of its interior angles are congruent to one another. Now, they're asking, name two triangles that are congruent. Do you guys have a guess as to which triangles we should aim for? Yeah.
STU and RVU.
STU and RVU. I agree. Right? Those look like some triangles that have a chance at congruence, a chance at happiness together, right? I think so. So if I know all of those congruences based on angles and sides because of the regularness of this pentagon, do I have enough information to prove triangles congruent? So triangle stew is congruent to triangle. Actually, I could name this either way because these are isosceles. RVU, I guess I'll call it. And the reason, side angle side. Good times, good times. I think that's all I did, right? Yeah, I think that is. Well, thanks for watching, Internet friends. Won't you have a great day?